Velebit AI with many years of professional experience in research and development of products based on deep learning and other machine learning approaches. He works on research and development of models based on the latest scientific accomplishments in the fields of computer vision, natural language processing, and dynamic system modeling. Let's give a round of applause so you can clap your hands some more for Mladen.
Hello everybody. Today I will talk about one common neural network architecture. It's called UNet, and the title says UNet is all you need. We'll see many different applications of this architecture for various domains and business problems. I'm a lead data scientist in Velebit AI, and I'll first tell you something about Velebit AI. So we are a software agency, AI software agency. So what this means, we are building, we are doing business-to-business development and providing services for various clients. So this could be in industry or in academia. You can see some of our clients listed on the slide. And what this means basically, we are doing business case analysis. We sit with our clients, we check their data. After that, we also check current articles. So there's a lot of research in our company. We're checking what's current. We also know what's proven, like UNet. Then we suggest some solutions. We typically then build some prototype. And what's important, like the last speaker said, we iterate a lot. So we check your data, we build something with that, we have some initial model, and then we move on to other things and to improvements. Depending on the use case, in some cases we also do deployment, not just prototyping. One big part of our business is also that we are doing software as a service for online classifieds. So we have a background in online marketplaces, and we have experience of 7 years of doing large-scale GPU deployment. So in some cases we are doing end-to-end, not just research, but also deployment in the end. So again, briefly, that's us, 4 co-founders. We are self-funded, on the market 3 years, but together as a team, we've been working for 7 years. So we have a couple of employees, and probably like everybody else here, we are hiring for more. Okay, so let's see, for the topic today, I'll speak about UNet. So briefly, this is a network that was originally developed for biomedical applications, but it can be used for many other different cases. So what this is something that's called a deep convolutional neural network, a bit of a technical term. And the problem that we are doing, it's image level segmentation. So segmentation can mean different things in different contexts. So here it's relatively simple to explain. So it's just the image, and you have pixels on the image. You want to say what it is. For example, you want to say yes or no. This pixel represents a brain tumor, for example. And the main limitation here, if you just use UNet, you won't distinguish different instances. So for example, if you have chairs on your image, well, the UNet will just say for each pixel whether is it a chair or not, and you would have to use something beyond UNet to actually separate the separate instances of chairs. Okay, so again, is it really all you need? So this is something from Twitter, and I must say I've been reading machine learning papers for a couple of years. I've read hundreds of them, and I mean, many of them could go into titles like this, like all you need. That's a popular catchphrase that happens. We can see some more. We got more compute and it works better. It always helps. More money often also helps, right? We got more data and it works better. So I must say, also some examples like cherry-picked results look great. You can see like many different things around in the literature. So here we have this title, All You Need, a popular catchphrase, so we'll see what's this about. And basically, okay, you shouldn't take it literally, right? So it's not really all you need, you will try other things, but you will often start with unit, and in some cases you will actually end with the unit solution. So, as hinted here on the slide, there are other things that matter more, so I'll speak about this in the end, the data-centric AI. In many cases you will get deployable solutions just by using unit or possibly by using some variation of the unit network. Alright, so just as an introduction, so unit initially it was developed for biomedical applications, for segmentation problems. So we can see here, in this case we are interested in blood vessel segmentation. So this is the output prediction that we get from the unit network. You're saying for each pixel whether this is a blood vessel or not. Or in this case we have some lesions that we are predicting here, skin cancer lesions. This is the original image, and here you have this output, whether it's a lesion or not. Similarly for the lung case, for lungs here, also we are segmenting them. So I'm showing you here some simple examples. It could actually be more categories. So notice that we have here two categories, background or not background, but you could have other classes. So you could have multiple categories, not just two. But this is the simplest example. And again, I have to say, so the paper unit, it came in 2015, and you can see here it's 2021 in this review paper. The thing is that actually unit and variations of unit are still very much used in different applications. So for example, we have here brain tumor segmentation. Here we have liver segmentation, and this is also part of liver, but this, here we have some lesions, areas of interest. So for many different applications, this is still very much used. It's a great robust architecture that people are still using, and it's not just something that happened a couple of years ago and not used anymore. Alright, so I'll briefly explain some technical details how this thing works. So, okay, you can see, first of all, it's U-shaped, so that's why you have this name unit. And, okay, we have some blocks, that's a bit technical. We have convolutional neural networks, so you can just, for now, see them as some processing blocks. And just to have an overview of all of this, what happens here, we have some input image here, and typically this is something that has 3 channels, or in some cases it could be just 1 channel image, right? You could have RGB images with 3 channels, or maybe grayscale, you just have 1 channel. And what happens here, you have this part where basically what happens, the number of channels increases. So in the end you might have like 256 channels and not just 3. And at the same time you are reducing height and width. That's what happens in this green part, and at this blue part you are going back, you're decreasing the number of channels and you're increasing height and width. And in the end you get one of those segmentation outputs that I've shown you. It could be binary ones where you have some tumor, and zeros where you don't have tumor, where you have background. So that's the simplest example. There are other technicalities here. So for example, this arrow here denotes skip connections. You're using something from before, adding it later, and this helps in segmentation. So this is something typical for the unit, this skip connection idea. Okay, so briefly that's what we have. This is our architecture, and it's used for many different applications. And I'll talk about the applications that we had in Velebit AI. So we did a couple of projects that were about medical segmentation. We did something that was quite interesting. It was about short-term rainfall prediction. A couple of other projects related to fluid dynamics. We also had one project about portrait background removal. Currently something that I'm doing, understanding document elements. In that case, also UNIT was a good baseline. And we're also doing some fashion approaches, fashion applications. Like I mentioned, a part of our business is doing software as a service for online marketplaces, and a fashion understanding is a part of that. So it's also something that's interesting to us. All right, so I'll first talk about medical segmentation. So like I said, we had a couple of projects there. And here you can see we did something again related to COVID. So this is something that was based on this challenge, COVID Segmentation Grand Challenge, where they published some open data. So I'm showing that data which was publicly licensed under this challenge. We didn't actually work on this challenge. This was something that we did for a client. So this client wanted some improvements. He added his own data, and we built upon the open challenge here to improve on that. So this was an interesting project, and I must say, generally, when doing medical segmentation, there are some tools that are helpful, like ITK Snap. It was used to create this image. Generally, MONAI framework, it's a great framework for doing any research and any applications that are related to medical applications. So it's based on PyTorch Ignite, so that's something that you could use for any deep learning approach, but MONAI also builds on this PyTorch Ignite to be more readily available for those applications that are interesting in medicine. And I have to say, of course, there are different variations here. So, for example, dynamic unit, that's something that I used here. And, of course, a simple unit was still a good baseline to try. These are the images from the same project. And what I want to say here is that we have to have in mind that actually this is a 3D project. 3D problem, right? So you don't just have slices in 2D, you actually have slices in 3D. So this is something that you have to be aware of, and you have to have some metrics that are related to 3D. And this is something that I also want to stress here. Here I'm illustrating another project that I did, and this was especially a great project for me to work on. I liked it a lot, so I was collaborating with a domain expert. So he's a radiologist in the United States. And basically he was very interested in segmenting internal organs. So I'm just showing this for illustration. I'm not showing everything between NDA agreements, so that's rather typical when you work with clients. But basically, again, it was some internal organ segmentation, and this was something that was interesting for him to recognize diseases. And what actually happened there, in the end, we got it in a stage where it's really great accuracy, and it's helping radiologists there to recognize things and check things faster. So previously, they would just have to check everything on their own, and they would have to use more time for that. So here, the idea is that you have something that works pretty great automatically, and then you still have somebody, a medical expert to check this. So, I mean, of course, this is something that's quite sensitive. It's people's lives, and you really want to have it like that. So I think this makes sense a lot to have something automatic, but then again, you need to have somebody to check it, and this is something that worked great for this project. I have to say also, it really matters to have a domain expert in your team, because there are various specifics that you don't know about. So, for example, when I started working on this, I never before worked with DICOM files or NIFTY files, And here we had different domains. You could have MRI images, in some cases CT images. So you can learn a lot from a domain expert. He will tell you things, speed up things, and this was a really great experience when I was collaborating with the domain expert. I was bringing deep learning knowledge, and then together we managed to build something that was quite useful for them. Okay, so to move on to another project, so this is something that we did in Velebit AI around 2 years ago. We were doing short-term rainfall prediction, so this is something that we were doing for the Croatian use case, so you can of course recognize the Croatian map here. So we are dealing with radar images, and here, here we have a time series prediction problem basically. We have a series of maps like this basically, so you have radar images and you have a series of them. And then, okay, we have it across time, and what you're interested in is you want to see, okay, whether there will be rain like in half an hour from now, or maybe an hour from now. So it's called nowcasting, because you're interested in something that's rather close to now. And the idea here is that basically, why did we try like this with neural networks? So the idea is that if you're using physical models, it takes time and effort, so it's expensive, it takes them some time to predict what will happen, and with neural approaches, you could do it faster and cheaper. So that's the idea basically. So you could take what's happening in the last couple of hours, and then you could predict something, what will happen in an hour or a couple of hours from now. So many teams are doing that. We built something that was a good prototype, and this is also something that's quite current right now, using deep learning to better predict weather phenomena. Okay, so basically I'll briefly explain what's the approach, how to use UNIT for such problems. This is actually something from a paper that was more recent. Other people are also working on such problems, of course, and basically in that paper they did something like we did as well. So they used this attention unit, and by the way, many of you also know attention is all you need is also a popular catchphrase in the paper, so this attention is also everywhere. And basically, okay, just to briefly explain the idea here, this part here is crucial. You just stack, in this case, 12 states, so they're stacking 12 images, let's say 12 radar images. They're separated by 5-minute intervals in their case, and then in the end, possibly you're just predicting what will happen in an hour from now, or whatever you wanted. You could predict maybe 30 minutes from now, or a couple of hours. You could have a single prediction, or maybe you could have a series of predictions. So you could have multiple channel outputs, not just one. And basically, that's something that we also did as well, and got some good initial results with this. Okay, so to sum up this use case, this is what you have in the end. You could just have, for example, a simplified version, binary prediction, rain or not, or you could also have something that's more complex. You could have multiple channels for each range track. That's also possible to do. I'll also mention another project. This is something that one other colleague from Velebit and I did for an American client. There still are a startup. They're interested in predicting weather phenomena as well. So it was about predicting pressure, volume, temperature, similar variables. It was also in the form of images. Again, I'm not showing the real image. I'm showing something similar, visually similar actually. So this is something for ocean currents, and we also had one project that almost got through regarding predicting variables related to ocean currents. I'm just showing here this image because it's quite similar. You often get from different domains similar formulations. So for this problem here that we did, we also had this formulation of multiple images, and we were predicting the next state. So that was the idea there. And I'm here just briefly mentioning there are different ideas, different things that you could try beyond units. So some of those ideas we actually tried, some of those we just explored. I'll just mention here that we got good results with generative adversarial networks. So this was something that was used to get more realistic predictions. So often when you have predictions like, you have originals like this, they are sharp, but often when you predict with neural networks, you get something that's blurred. And we got great results with general adversarial networks to have sharper predictions. Okay, so moving on to the next use case. So this is something that we actually deployed. So the idea here is for selfies to remove the background. So this is also a typical popular use case. In this case, it was beneficial to actually, beyond foreground segmentation, it was beneficial to also predict the boundary. And what's interesting here, so we often, like I said, check different papers. So we got a nice paper here, and actually they didn't use unit in that paper. And in the end, we actually got better results by switching this network with unit. So that was rather funny. So this result here, I checked the results, the logs. I checked it recently, and actually the variation which had unit got slightly better accuracy and a better performance. So like I said, this is still quite common that this architecture really does well, even better than some other newer approaches. Again, something just for illustration. So this is again not a real image, just an illustration. This is something that I'm doing for a client right now. It's about understanding documents. And the idea here is that you can have unit, for example, predicting numbers, recognizing numbers. So it will annotate where the numbers are. Or, for example, for text, it will also annotate where the text is. And here we have some graphic. It's outputting yellow, which represents charts. So that's something that I'm currently working on, and the unit got initial good results on this. Like I mentioned, we are also interested in fashion approaches, fashion applications. What we have as a software as a service, we have this visual recommender system, and basically the idea here is that what you do, you have images, and then you represent them somehow mathematically as vectors, and then you can compare those vectors and find similar vectors and in turn similar images. So one thing that's interesting to us is, well, we don't want background to influence visual similarity. So one approach here in this paper, coding parsing again with unit, some variation of unit, you can not only separate the background, but you could also get different clothing articles, different clothing items, and then this could also be interesting to us to have a separate vector for each of the clothing items. So that's also something that we are currently looking into. In the end, okay, I can show you, well, this is our meeting table and also our dining table. We have lunch here in Velebit AI. This is my chair as well. What I want to show you here is that, okay, in practice you will also move beyond unit. We don't have a purple dining table, so this is segmentation prediction. I think it's getting the table quite well. Also for the chair, it's actually black. And here, you probably don't see it, you actually also have bounding boxes prediction. So it's a tiny red box around each chair and around each table. So for the unit, you would have to do something else to separate the different instances of chairs. When you move beyond that, you also often have bounding box predictions along the segmentation part where you tell everything for each pixel. And lastly, what I have to say, here I want to mention again, it's all about data and all about iteration. So in many cases, you will get great results with simple models, and then you will have to check the data. So that we had multiple cases like that where we analyzed the mistakes, and then, like for example, in that project that I was working with the American radiologist, he actually organized the labeling. He saw immediately, okay, so, well, this wasn't labeled in a good way, let me relabel that, let me reorganize the labeling. In some cases, labels are not consistent, so you have to take care of that. And let's maybe just have a show of hands. So how many of you know this guy here? So let's just have a quick show of hands. Okay, so many of you, about half, I'd say, know who Andrew is. So a co-founder of Coursera, Stanford professor. He was working also in Baidu. He's a pretty famous guy. And I have to say, I also started my journey as well 10 years ago by taking his courses. So nowadays he is doing this data-centric approach, data-centric AI movement, and there was recently a workshop on the largest, or one of the largest conferences and most important conferences in the world. So this is something that's also academically interesting nowadays, how to better systematically improve on your data. I'm running out of time, and I'll just say thank you, and I'm open for any questions now and also at the breaks. So thank you for your attention.
Do you maybe have some questions? I'm sure
We
you
have
do.
one there.
Yeah. Can you just maybe please raise your hand so we can see you again? Over there in the back row, right?
Just raise your hand, please.
There was no question?
Maybe they got shy.
Maybe somebody just,
Or just stretching their
scratched
head.
the head. Okay, if anybody changes their mind, this is the opportunity.
And you can catch me later if you want to talk about more
Lunch break will
specifics.
be soon.
There are many things here and many details that we could discuss if you're interested.
Okay, thank you.
If not, thank you again for your time.
Thank you, Mladen.